Hey folks, it's Klepik here, and today we're diving into the world of nitric oxide scrubbers. Trust me, this one's more exciting than it sounds. Nitrogen is all around us, but when it bonds with oxygen, things get a little, well, hazardous. So, how do we handle these potentially dangerous compounds in the air? Let's find out together. Understanding nitric oxide and its danger. Nitrogen N by itself is pretty harmless. In fact, it makes up a good portion of the air we breathe. However, when nitrogen meets oxygen, it forms nitrogen oxides, NOx, and that's where the trouble begins. Let's break down the key nitrogen oxides. Nitric oxide, NO, a colorless toxic gas that can bind to hemoglobin in the blood, reducing oxygen transport. While it's harmful, it doesn't stick around in the atmosphere for long. Nitrogen dioxide, NO2, a brown, highly toxic gas that causes significant respiratory problems and can even contribute to acid rain. This one is the real troublemaker. Nitrous oxide, N2O. Commonly known as laughing gas, it's used as an anesthetic. Unlike NO and NO2, this one's not as dangerous, but we're more concerned with NO2 in industrial emissions. Now, why should you care? NO2 can severely irritate your lungs and mucous membranes. Prolonged exposure can lead to chronic respiratory problems, including lung damage and asthma. Plus, NOx compounds contribute to environmental issues like acid rain and smog. So how do we deal with it? That's where wet scrubbers come into play. What are NOx wet scrubbers? NOx scrubbers are devices designed to remove nitrogen oxides from industrial exhaust before it can enter the atmosphere. They are widely used in places like power plants, chemical facilities, and refineries, basically anywhere with high NOx emissions. The most common method for NOx removal is absorption. Wet scrubbers use liquids, often sodium hydroxide or another reactive chemical, to absorb and neutralize harmful NOx gases. Here's how a basic NOx wet scrubber works. Gas entry. Contaminated gas enters the scrubber through an inlet. Water or solution spray. As the gas passes through the scrubber, it's sprayed with a liquid, often sodium hydroxide. This liquid reacts with the NOx gases, turning them into less harmful substances like sodium nitrate, NaO3. Filtration. The gas passes through various filters, like packed beds or nozzles, which maximize the contact between the gas and the liquid to ensure high removal efficiency. Purified gas exit. After the gas has been scrubbed, it exits the device through an outlet, now much cleaner than when it came in. Sludge collection. Any solid byproducts, like sludge, are collected and removed for further processing. Types of NOx scrubbers. Let's talk scrubbers. There are different types depending on the specific needs of the facility. Here are the primary types of wet scrubbers used for NOx removal. 1. Spray tower scrubbers. These scrubbers work by spraying the gas with a liquid from nozzles. The liquid absorbs the NOx gases, transforming them into less harmful compounds. Spray towers are relatively simple but effective for gases with low NOx concentrations. 2. Packed bed scrubbers. Packed bed scrubbers use structured packing materials to increase the surface area for gas-liquid contact. This makes them more efficient than spray tower scrubbers. The gas flows through the packed bed, where it interacts with the scrubbing liquid. Packed bed scrubbers are particularly good for handling high NOx concentrations. 3. Venturi scrubbers. Venturi scrubbers operate by forcing the gas through a narrow throat, where it speeds up and collides with liquid droplets. The high velocity enhances the absorption of NOx, making this type of scrubber highly effective for fine particles and gases. Venturi scrubbers are often used for high-temperature emissions and larger-scale operations. Chemical reactions in NOx scrubbers. The efficiency of a wet scrubber often depends on the type of scrubbing solution used. The most common chemical for NOx removal is sodium hydroxide, NaOH. Here's what happens inside the scrubber. In this reaction, sodium hydroxide neutralizes nitrogen dioxide, producing sodium nitrate, NaO3, and water. This is one of the most effective methods for reducing NO2 emissions. Ammonia, NH3, can also be used in NOx scrubbers, reacting with nitric oxide, NO, to form nitrogen gas, N2, and water, H2O. This process is often called selective non-catalytic reduction, SNCR. Other reagents used include sodium carbonate, Na2CO3, and urea, NH2CoNH2, both of which can neutralize NOx gases through similar chemical reactions. Materials used in scrubber design scrubbers must be built from materials that can handle the corrosive nature of NOx gases and the chemicals used in the scrubbing process. Some of the most common materials include polypropylene, PP, resistant to many acids and alkalis, making it a good choice for the internal components of scrubbers. Stainless steel, AIC 304 or 316, frequently used for the external structure due to its durability and resistance to corrosion. Teflon, PTFE, a great choice for coating surfaces that come into direct contact with highly corrosive gases. Each material has its strengths, and the choice depends on the specific conditions of the facility, such as temperature, gas composition, and chemical reactivity. Other methods for a NOx removal. While wet scrubbers are effective, they aren't the only way to deal with NOx. Here are a few alternatives. Catalytic reduction. This method uses catalysts, such as platinum, to convert NOx gases into nitrogen and water. It's very efficient but also more expensive than wet scrubbing. Adsorption. Adsorption systems use materials like activated carbon to physically trap NOx molecules. This method works best for small-scale applications. Combustion control. By adjusting the combustion process, you can reduce NOx formation at the source. This method is often combined with other forms of scrubbing or filtration. Carbide method. This chemical process converts nitrogen dioxide, NO2, into less harmful compounds, achieving up to 95% purification. Maintenance and efficiency. To ensure your NOx scrubber works at peak efficiency, regular maintenance is crucial. Inspecting the scrubber for clogs, leaks, and other issues can prevent downtime and costly repairs. Automated control systems can monitor things like pH and liquid flow rates, making sure everything runs smoothly. Some key points to remember. Wet scrubbers can remove up to 99.9% of NOx emissions. Different chemicals like sodium hydroxide and ammonia are used to neutralize NOx gases. The material used in the scrubber must resist the corrosive nature of the gases and scrubbing chemicals. And that's it for today, folks. Nitric oxide scrubbers might not sound like the most thrilling topic, but they're essential for keeping the air clean and safe. Whether it's handling NOx emissions from a power plant or a refinery, wet scrubbers are up for the challenge. So next time you're walking by an industrial plant, take a deep breath. Those scrubbers are working hard so you can breathe easy. Until next time, scrub away those emissions and keep the air fresh.